Solve the equation tangent of theta plus 1 equals secant of theta. First, we need to combine like terms. With tangent theta and secant theta, they don't have anything in common, but we remember that there is a relationship between tangent squared and secant squared. They are the Pythagorean identity from cosine squared theta plus sine squared theta equals 1. To obtain tangent, we would divide it by both sides of this equation by cosine squared theta. Cosine squared theta over cosine squared theta is 1. Sine squared theta over cosine squared theta is tangent squared theta, and 1 over cosine squared theta is secant squared theta. So there is a relationship between tangent squared and secant squared. Because of this, we will attempt to square both sides of the equation. We take tangent of theta plus 1 on the left and secant of theta on the right, and we square each side. Tangent theta plus 1 squared is tangent of theta plus 1 times tangent of theta plus 1. And the right hand side is secant squared theta. FOIL this or distribute, we get tangent squared theta plus tangent theta plus tangent theta plus 1. And the right hand side is secant squared theta. We can just simply use the identity in this case. This is tangent squared theta plus 2 tangent theta plus 1 equals secant squared theta. And we replace tangent squared theta plus 1 with secant squared theta. This is the identity. The left hand side is now secant squared theta plus 2 tangent theta, and the right hand side is secant squared theta. We then zero this out by subtract secant squared theta from both sides of the equation to get 2 tangent of theta equals 0. So tangent of theta equals 0. On the unit circle, tangent of theta is defined to be y over x. For tangent of theta equals 0, y needs to be 0. So we draw the line y equals 0. This line intersects the circle at two places. One is theta equals 0 and the other is theta equals pi. But every time we square the equation, there might be an extraneous solution, so we need to double check this. When theta equals 0, the given equation is tangent of theta plus 1 equals secant of theta. The left hand side is tangent of 0, which is 0. 0 plus 1 is 1. And the right hand side, secant of 0 is 1 over cosine of 0, and cosine of 0 is 1. So theta equals 0 checks out. This is a good and correct solution. When theta equals pi, the left hand side of the given equation is tangent of pi plus 1, and the right hand side is secant of pi. Tangent of pi is 0, so the left hand side is 0 plus 1, which is 1. Secant of pi is 1 over cosine of pi, but cosine of pi is negative 1, so 1 over negative 1 is negative 1. This solution does not work. This does not check out. So the only solution to this given equation is when theta equals 0 in the interval 0 to 2 pi. We then obtain the general solution. Although tangent of theta has a period of pi, but we know that we cannot add pi to this because theta equals pi is not the solution. So theta equals 0 plus 2k pi, or simply 2k pi, where k is an integer in this case.